Hey there, this is covalent bonding, day 4. Today we're going to talk about intermolecular forces, and those are the forces of attraction between molecules, not between two atoms in a molecule, but between the molecules themselves. There's three types of intermolecular forces. There's dipole forces, there are London dispersion forces, and they're hydrogen bonding. Intermolecular forces are weak in gases. That's what allows the gases to be far apart from one another, because there's not that force of attraction between the gas molecules. Intermolecular forces are stronger in solids because there is a great deal of attraction between the molecules in a solid, which is what makes a solid solid. Okay, the first type of intermolecular force that we'll talk about are London forces, and they're very, very weak forces. These are the weakest types of forces. They result from temporary charge imbalances, and they exist in nonpolar compounds. So if we had a chlorine, okay, just diatomic chlorine, okay, we have a chlorine, and electrons, okay, and then another chlorine. All right, we're in a sample of chlorine gas. What happens as these chlorines move close to one another, okay, as that chlorine moves close to that chlorine, the electrons that are here, the electrons over here, are going to repel one another. So these chlorines on this side of the molecule might temporarily move that direction. When they do, that'll cause a very slight temporary negative charge on this side of the chlorine. Even though it's a nonpolar compound and those electrons are equally distributed, the forces of these two electrons repelling one another is going to cause the electrons to move just for a very short period of time, creating a very momentary positive negative polar type compound. So that's the force of attraction that holds those nonpolar compounds together. Again, they're very weak forces of attraction, and they happen just very, very quickly. And they only happen in nonpolar compounds when the electrons move just for a very short period of time, causing a very slight positive charge on one end, slight negative charge over here, and so those two compounds will attract to one another, or those two molecules of chlorine would attract to one another. Next type of force that we'll talk about is a dipole force, and these occur in polar molecules. Okay, the molecule has to be polar. Here we've got the example of hydrochloric acid. It's polar because there's lots of electrons here, and another HCl. So this end of the molecule is very negative, and this end of the molecule is very positive. Okay, the electrons are attracted to the chlorine. Well, same thing over here. This molecule is positive, this end of the molecule is positive, and this end of the molecule is negative. Why? Because the electrons are attracted to chlorine. Well, there will be a force of attraction between the negative end of this molecule, of this HCl molecule, to this HCl molecule. This one's positive, this one's negative. So it's those positive and negative ends that are attracting one another in a dipole-dipole interaction. So the hydrogen end of the hydrochloric acid is permanently positively charged. The chlorine end is permanently negatively charged. The hydrogen in one molecule is attracted to the chlorine in the neighbor, just like that. The intermolecular force is weak compared to a covalent bond, but again, we're talking about whole compounds being attracted to one another, not a bond attraction, all right, a bond force. The last type of intermolecular force, and the strongest type of intermolecular force, is hydrogen bonding. And I kind of think hydrogen bonding is the easiest one to remember. Hydrogen bonding occurs when the compound has a hydrogen bonded to either a fluorine, an oxygen, or a nitrogen. So things like hydrofluoric acid, or water, or ammonia. Okay, in each one of these, the hydrogen is bonded to either a fluorine, an oxygen, or a nitrogen. Okay, that causes the force of attraction to be very, very strong between like HF molecules. Right? So it will be strongly attracted to another HF molecule, because Fluorine is very, very electronegative, so there's lots of electrons over here. And hydrogen is more electropositive because all the electrons are over here. So there will be a great deal of attraction between the negative end of the fluorine and the positive end of the hydrogen. Hydrogen bonding, by the way, is responsible for the expansion of water when it freezes. Water's kind of neat. A lot of things, when they turn from a liquid to a solid, they will contract and get a little bit smaller, but not water. When water freezes, it expands, which is the reason in the wintertime, if your pipes freeze, if the water in your pipes freeze in your house, the pipes will break. It'll expand ever so slightly, causing the pipe to burst. The water molecules in the solid state have a tetrahedral spatial arrangement for the 2 lone pairs and the 2 single bonds that are coming off the oxygen. The lone pairs on the oxygen are attracted to nearby water molecules through hydrogen bonding, and it makes like a cage structure, like up here, a cage-like structure. And it causes the water to expand ever so slightly as it rearranges in the solid state and gets a little bit bigger. So that can be a problem for the pipes in the wintertime. So those are the 3 types of intermolecular forces. Just the hydrogen bonding is the strongest. The London forces are the weakest. Remember that. London forces are going to occur between nonpolar molecules only. Dipole forces require that the molecule be polar. Okay, this would be like that. This would have to be polar. And then hydrogen bonding, don't get tricked. Both of these have hydrogen, but remember, in hydrogen bonding, the hydrogen has to be attached or bonded to a fluorine, an oxygen, or a nitrogen. Okay, so good luck.